everyone, and welcome to the second installment of our 2025 OSHA webinar series. Thank you very much for joining us. Today, we'll be talking about hidden hazards, key considerations in industrial hygiene, covering both your traditional chemicals like lead and silica, as well as combustible dust. I'm glad we're discussing this today because, as the name of our webinar suggests, these are often less obvious hazards. Where you might be able to quickly notice, a broken guard on a machine or a tripping hazard on the floor. These tend to be invisible and require testing to determine if they are at hazardous levels requiring attention. We have a lot to cover, so without any further delay, let's jump in. I'll let my colleagues Tony and Val introduce themselves, but I'll just do a quick intro myself. My name is Bita Lashkari. I'm a partner in the OSHA Workplace Safety Practice Group at CMC. And before joining the firm, I was an attorney investigator at the U.S. Chemical Safety Board, or CSB, where we focused on investigating catastrophic accidental releases, including, and me personally, combustible dust explosions. So again, very happy to be speaking with you all on this topic, and I'll pass it on to Val, who will be speaking with me on combustible dust.
Thank you, Bita. Hi, everyone. I'm Valerie Butera. I've been a workplace safety attorney for 22 years, always on the employer side, representing employers and trade associations in a wide array of workplace safety issues. My primary focus these days is chemical hazards, manufacturing, and process safety management. And I'm excited to join you today.
Good afternoon, everybody. My name is Anthony Castelletta. I am an attorney here with Maciel Carey as well. I'm based out of the Detroit area office. I've been an attorney for going on about 6 years now. Before becoming an attorney, I was with Michigan OSHA for 18 years. So my background is a little bit more unique in that I am a true traditional health and safety professional that became an attorney as part of his midlife crisis. So for my background, I have both a bachelor's degree and a master's degree in industrial hygiene. While I was with Michigan OSHA, I did compliance work in both general industry and construction in industrial hygiene, focusing on airborne exposures in manufacturing facilities, as well as at construction sites and other facilities throughout the state. I was also part of the MyOSHA asbestos program. I was their licensing and accreditation specialist, where I handled their contractor and training, licensing, and accreditation for their contractors and the employees. And I was also a MyOSHA supervisor of the health and construction side of things, where I oversaw first line appeals and also engaged in litigation with the Assistant Attorney General. So interesting background, and one of the reasons why I'm on here is because I'm very excited to be able to talk about industrial hygiene. Both Val and I were talking before we got on here. It's just, we have these nerdy sensibilities that no one really seems to appreciate until they need to. But, one of these are things that we're very excited to talk about, specifically industrial hygiene and Bita with dust, and, Val with her dust background as well. So we'll get into the agenda for today, because we definitely do have quite a bit to talk about, and we're excited to share with you. So as far as our agenda goes today, I'm going to kick things off with just a basic overview of industrial hygiene and how OSHA interacts with the industrial hygiene field. We'll then kick it over to Bita and Val to go over combustible dust. We'll talk about the combustible dust standards and enforcement, combustible dust hazard identification, and combustible dust hazard prevention and mitigation. So getting into OSHA and industrial hygiene. So industrial hygiene is the science devoted to the anticipation, recognition, evaluation, and control of those environmental factors or stressors arising in or from the workplace that may cause sickness, impaired health and well-being, or significant discomfort among workers or among citizens of the community. Industrial hygiene includes the development of corrective measures in order to control health hazards by either reducing or eliminating the exposure. These control procedures may include the substitution of harmful or toxic materials with a less dangerous one. And this is obviously one of the things that we often try to focus on when working with a client is if we have an issue with a specific product, is there a less hazardous product that we can implement? Earlier or last year, I was working with a pharmaceutical company that was using pretty significant and pretty hardy decontaminant solution that contained high concentrations of peroxide and acetic acid and peracetic acid. All three of those regulated by OSHA and can be quite problematic to control. We had identified some overexposures, very significant overexposures to hydrogen peroxide. Fortunately, in working with the pharmaceutical supplier and some of our other vendors, we were able to identify a less hazardous compound that had a lower concentration of hydrogen peroxide, which therefore reduced the amount of exposure to the employees. So sometimes it can be difficult, to kind of figure out what products that we want to use and how to solve these things, because a lot of times it's like just throw people in a respirator or let's just crank up the ventilation, which is not always possible. Sometimes just identifying some additional another product, there's other products out there that can work, but so you always want to make sure that you're looking at those. Changing the work process to eliminate or minimize the work exposure. This can be done through either automation or simply just modifying the position of an employee. I've got a couple clients right now that I'm working on. One is doing a significant amount of welding on stainless steel, and it's a very process. It's a very hands-on process that the employees really need to get into these nooks and crevices to make these welds, and it's very difficult for them to, for us to, implement some specific engineering controls, but really what it comes down to is just, modifying the positioning of the employee, how they're going to stand, and creating an awareness for them to position themselves so they're not in this fume plume when they're doing their welding. So things like that to kind of take, for, just working on changing the work process. Installation of exhaust ventilation, either through local exhaust ventilation, downdraft tables, whatever it may be. Sometimes, again, it may be something that could work for your company. Sometimes just not going to work for the process at all. So again, things to look at. Good housekeeping, and good housekeeping is it's often an overlooked item of industrial hygiene as well, but it's essential. It's an essential part of industrial hygiene. And we see this is a good housekeeping as a way of making significant and positive impacts on the wellness and health of the employees, with whether it's going to be lead, where we're seeing an increased amount of cleaning of surfaces and going in and out of certain areas to eliminate track out, or just to make sure that the workers do not have any high concentrations of lead or other material on their hands, possible ingestion issues. Yeah, you see it for lead, we see it for arsenic, we see it for cadmium, asbestos, and more recently we're just seeing a significant amount of enforcement activities in formaldehyde. So there's some housekeeping issues that can go along there to kind of help reduce employee exposures to that compound as well. And then finally, we get into the use of personal protective equipment. And this is, we want to use PPE when necessary. It's important to note, PPE, specifically respiratory protection, is often the last resort with regards to the hierarchy of controls for industrial hygiene. So you want to make sure that you're trying to eliminate the hazard or controlling the hazard before you're placing employees into personal protective equipment. It's the least, it's the last resort. And very often, OSHA wants to see some form of engineering or administrative controls put into place or exhausted before you're going to rely on personal protective equipment. And the reason for that is the employees are still exposed to the hazardous compound at issue. Just throwing putting a respirator on an employee or putting him in personal protective equipment doesn't eliminate the hazard. The hazard is still there. They're just protected through the use of personal protective equipment. So again, an effective industrial hygiene program, it does involve the anticipation or recognition of health hazards arising from work operations and processes, evaluation and measurement of the magnitude of the hazard, and implementing effective control over the hazard. Again, this can be quite difficult and costly. This is where you see the difference between health side of things and industrial hygiene versus the safety side of things, which is just, hey, maybe we just got to put a guard on this piece of equipment, or put a barrier up for fall protection or whatever it may be. The implementation of re-engineering a process through ventilation or a new compound can be very difficult and time consuming. So yeah, so make sure that you're working with your health and safety staff and your industrial hygienist when you're moving through and identifying these issues. So industrial hygiene and OSHA. OSHA has implemented mandatory health and safety requirements that are applicable to millions of workplaces throughout the country. OSHA enforcement activities will typically include either a safety inspector or an industrial hygienist like myself when I was doing my field work. In some circumstances, you're going to have both. You're going to have both a safety officer and a compliance industrial hygienist out there. And a lot of it's just going to depend on the type of investigation, type of hazard that they're seeing out there. The OSHA industrial hygienists are going to be typically trained to analyze, identify, and measure the workplace hazards or stressors that can cause sickness, impaired health, significant comfort, everything that's going to be associated with industrial hygiene. They typically have a degree in industrial hygiene, sometimes more of an advanced degree too, just depending on the type of operation that they're going to be looking at. But it is the role of OSHA's industrial hygienists to identify these conditions, to help eliminate and control them through the evaluation of the company's compliance with the established OSHA rules and regulations. And depending on the compound, the exposures may be controlled by a chemical specific standard, or by comparing employees' exposures to limits that are outlined in OSHA's 1910-1000 Table Z. And I'm sure most of you, if you are out in the field or working in the workplace, that have had an industrial hygiene monitoring event, whether it's through a consultant or through an OSHA compliance investigation, are familiar with Table Z. So Table Z is a list of occupational exposure limits. They're called permissible exposure limits of various compounds. And these limits are expressed as, like I mentioned, permissible exposure limits, and is basically what an employee may be exposed to over an 8-hour time-weighted average. So it's an employee. So I was out at a project the other day, and employees were being sampled by an OSHA compliance officer for painting fumes. The painter that was doing the painting was only painting for 2 hours. So OSHA set up monitoring for that employee for 2 hours. So they sampled that employee for 2 hours, but the rest of that 6 hour, the remainder of that 8-hour shift, 6 hours, the employee was doing something completely different and was not being exposed to the compounds from the painting operation. So the limits that are going to be compared for that full 8 hours. They'll take that 2 hours, but it's going to be extrapolated over the full 8 hours. When I say extrapolate, I don't mean they're going to assume the same exposure over the 8 hours. It's going to be averaged over those 8 hours. So if that employee was exposed to 10 or 8 for those 2 hours over the remainder of the 6 hours that he wasn't going to be exposed to, it's going to be assumed that he was exposed to a 0, and then therefore the limit's going to be, their average exposure is going to drop, and that's what's going to be compared to the permissible exposure limits that are outlined in Table C. One thing, another note, just from a nerdy industrial hygiene side of this, is that the Table Z information is woefully out of date. And this is something that OSHA recognizes, and you may hear a little bit of this if you're dealing with a compliance officer during their investigations. That most of the OSHA permissible exposure limits were issued shortly after the adoption of the Occupational Safety and Health Act in 1970 and have not been updated since that time. They were updated in 1989, in January of 1989, They updated a significant, updated around 212 substances, increased the permissible exposure limit for one, set new PELs for 164 other substances that were not previously regulated. However, it was the subject of several legal challenges, and in 1992, the U.S. Court of Appeals in the 11th Circuit vacated the more protective PELs set by OSHA in 1989, thus moving them back to the PELs from 1971. So what we're dealing with is some very, very old and antiquated levels. But what happens is when you're seeing these interactions with OSHA, oftentimes they're going to see references to the Cal OSHA PELs or to the NIOSH recommended exposure limits or the ACGIH TLVs. And these are just as a ways for OSHA to promote more protective contaminant levels for the employees. And this information with the NIOSH levels, the Cal OSHA levels, and the ACGIH TLVs, OSHA has established annotated tables in their website. If you're ever interested in looking at getting that information, or you can always reach out to us. We'd be more than happy to do that. And I know I'm talking a lot about exposure limits for compounds and chemicals, but OSHA industrial hygienists also address occupational noise. That's one thing that you'll typically see the IHs handle. Also, personal protective equipment and respiratory protection are a few other items that OSHA IHs typically focus on when they're doing their regulatory enforcement activities. A few other health hazards before we get into the combustible dust. Nuisance dust, carbon monoxide, metals, and chemical specific compounds. Those are things that we typically see a lot of. But the high flying, the more frequent flyer ones I see that we've been seeing a lot of action on are the nuisance dust. Typically, they'll be listed as particulates not otherwise regulated. And we see a lot of these problems with manufacturing and just general manufacturing, but also in food service industry, food service manufacturing, where you have a lot of dust generated from different types of food compounds, sugar, flour, whatever. And we'll talk a little bit about that when we get into the combustible dust. But the permissible exposure limit is 15 milligrams for total dust and 5 milligrams per cubic meter for respirable fraction. And the reason I put these up here is just to kind of just give you just a general understanding of these two different limits. So the 15 milligrams per cubic meter of total dust, that's just the dust that's floating around in the air. That's if you were to walk into a facility and you really can't see a whole heck of a lot what's going on. That's just the dust that's floating around in there. And the limit for that is 15 milligrams per cubic meter. And that's a pretty high level. I mean, it has to be pretty dusty for you to reach a level of for the 8-hour time weighted average for that. 5 milligrams per cubic meter is the respirable fraction, and the respirable fraction is a smaller size particle that can penetrate deep into the lung, and that can generate some respiratory disorders. Crystalline silica is one that's based on the respirable fraction portion of it. So again, it's a different sampling media that when OSHA comes out to do the evaluation, that they use to identify a specific size of particle that can penetrate deep into the lung. And so there's a lot, we see a lot of sampling for that. Carbon monoxide is another pretty frequent compound that we see OSHA looking at, and we're going to see a lot this time of the year too, with portable heaters, warehousing facilities that are they're closing their doors just because it's cold outside, but we have a lot of propane powered or just regular gas powered pieces of equipment running in and out throughout the facility. And what that does is that can generate significant concentrations of carbon monoxide. So be aware of these things. It can kind of sneak up on you, especially carbon monoxide, as the symptoms can be masked. They're pretty generic, headache, lightheadedness, tired, people coming in today, the day after the Super Bowl, probably experiencing some similar symptoms today, but, I don't necessarily know if it's associated with carbon monoxide, but again, something to kind of be aware of when you, for just general industrial hygiene and good health and safety for your facility. And then finally, metals. And these are, I mentioned lead, cadmium, hexavalent, chromium, just because these are some of the compounds that I've been seeing a lot of action lately. But The lead, cadmium, hexavalent, chromium, these are all what we call expanded standards. These are all chemical specific standards that OSHA has their own specific standard for. And if you look beyond Table Z into 1910, 1000 and beyond, this is when you're going to get into the regulations that cover these chemical specific standards. And most of them are pretty much follow the same formula. Each compound is going to have a specific permissible exposure limit. They may have an action level that certain items kick in at those times, but they all pretty much follow the same item. They're all going to include requirements for exposure monitoring, requirements for engineering controls, information on respiratory protection. Very often, medical surveillance and medical removal procedures. We'll see that for lead, cadmium, arsenic, when they're talking about concentrations of these metals in their blood. The development and implementation of a written compliance program, specific employee training, specific personal protective equipment and hygiene programs, whether it's showering facilities, hand washing facilities, then you get into housekeeping. So all of these standards pretty much follow the same formula. Again, just letting you know to kind of be aware of this before we just start focusing on combustible dust. So all of these are out there, and OSHA does look at them. And all of these things can be problematic if not properly controlled. A couple more things I just wanted to talk about before we get off the industrial hygiene kick here is air contaminants and mixtures. So I know I already discussed the permissible exposure limits in their limits, but there is a very unique way that these standards and these limits can kind of work together in a way that many employers are not overly familiar with. One of them is called cumulative exposures, and I've only seen this a handful of times, but I just wanted to kind of touch on this. Is that these cumulative exposure in the air contaminant standard? There's a specific calculation that can be used when dealing with compounds in a mixture or different compounds that affect or target the same body organ or physiological system. So if it affects the central nervous system, it affects the lungs, the liver, the kidney, etc. OSHA can use this cumulative exposure and this calculation to identify an exposure, even though you may not be above the permissible exposure limit. If you have several compounds that you're exposed to, they can run a calculation, and that if this calculation shows that you are over one, there's a lot that goes into this, but if you're over one, this could possibly classify as an overexposure. Again, it's not something that we see very often. I saw it in a pharmaceutical facility where they were using different solvents, and these solvents, while by themselves there was no overexposure, having them all used at the same time, all these exposures together created this cumulative effect that actually pushed the employer over this cumulative exposure rule. So again, not something we see very often, but again, something to be aware of. And then finally, the engineering controls for overexposures. This is very important to understand for employee exposures. We see requirements for engineering controls in some of these expanded standards, but typically when we have any overexposure to any of the compounds in Table Z, OSHA will likely issue a citation under this specific rule, this 1910-1000 E as in Edward. And it ends up being kind of the burden on the employer to show that we've done the best we can to implement engineering controls. If there is an overexposure, engineering and work practice controls are the primary means to reduce and maintain employee exposures below the PEL. Again, when OSHA is issuing a citation for overexposures and engineering controls, they're going to provide you with several recommendations for administrative controls, such as change your work practices, bring in reduce the amount of time employees are going to be doing something, or implementation of some kind of localized ventilation. The implementation of these engineering controls are often very expensive, especially in these highly regulated industries like pharmaceuticals or food manufacturing. The implementing of these changes or improvements to the existing ventilation system can often cost hundreds of thousands of dollars. So in practice, OSHA considers, let me back up here a little bit. I just want to kind of look at some of the language that we have in here. And I highlighted the word feasible here. And I wanted to talk about feasible here. In practice, OSHA considers technological feasibility as what is achievable using work practices or engineering controls that are commonly known, readily available, and currently used to some extent in the affected industries or processes. It is important to be aware of this and to keep up and be aware of the technology and understand what is available, what technology is available, and how it will affect your work operation. And I've seen it become a bit of a problem with certain employers where they've implemented engineering controls 15, 20 years ago, and they haven't done anything with it since. They haven't reevaluated anything. And then OSHA comes through, identifies an overexposure. The employer says, oh yeah, I know we had an overexposure. We implemented engineering controls. This is the best we could do. And that's why we have everybody in respiratory protection. And the OSHA's like, well, when was the last time you evaluated this? And we're like, we haven't. We did this. This is something we implemented back in, 2012 or whatever it may be. And OSHA was like, well, have you looked at additional engineering controls? Have you looked at the technology? Has it changed? And the employer hadn't. And then OSHA ended up issuing them a citation saying, you still need to make sure that there is feasible engineering controls. You haven't really exhausted this. You haven't really looked into this very, very well to determine whether or not it is feasible. And in doing that and doing the analysis for it, what an employer has to do is just, does it make sense to implement, this feasibility? Does it make sense economically? Is this something that you're seeing in industry? It doesn't make sense to implement a $700,000 technology that's going to reduce your total dust exposure from 21.5 milligrams per cubic meter to 1.5 milligrams. Probably not, because there just is not a significant impact on the employee exposures. However, if there is a new welding gun, for example, with a localized ventilation system that captures welding fume, and that reduces employee exposure by 75% at a cost of $10,000, that is something that you could probably adopt and implement here in the industry. So something you could consider. So again, it's very industry dependent, but something that you need to be aware of, as the ignorance of this improved technology can significantly hurt you. So that's all I have for industrial hygiene overview and going over the table Z and some of the expanded standards. So now I will pass this over to my colleagues to talk about combustible dust.
Great. Thank you so much, Tony. So before we get into the regulatory aspects of combustible dust, we thought it would be helpful to review the hazard because it is a lesser known hazard, I'd say. That was one thing we were very aware of at the CSB, is how do we spread the message about this in the broadest way possible. And while, hopefully it's not a common hazard, or that, combustible dust explosions are not common, the frightening thing is that, of course, when they do occur, they're often very severe. So we just wanted to cover the hazard first. So what is combustible dust? Broadly, combustible dust are fine particles that present an explosion hazard when suspended in air under certain conditions. We typically think of, the fire triangle with the three sides being, fuel, ignition, and ignition source and oxygen. You can see that on the slide there with the yellow triangle. With the dust explosion, we add two more sides, making an explosion pentagon. And those two extra sides are confinement and dispersion. And that's on the right side there with that red pentagon. And combustible dust is your fuel. And we'll get into this in later slides, but basically the triangle and pentagon are helpful because in considering prevention methods, what we want to do to avoid a fire or a dust explosion is eliminate one of the sides, right? So if we can eliminate all ignition sources, we should not have a fire or a dust explosion for that matter. And with a dust explosion, if we eliminate the possibility of dispersion, dust getting lofted into the air, that should eliminate the explosion hazard. But often that's, as you can imagine, much easier said than done. And again, we'll get into that later. Val will speak to prevention methods. But basically, if dust from a combustible material is suspended in air in the right concentration under certain conditions, it can become explosible. And even materials that do not burn in larger pieces like aluminum and iron, given the right conditions, those can be explosible in dust form. So all to say, the existence of the hazard is very sort of condition specific. Okay, so if we're talking about explosions, how do they occur? Well, they can either be primary or secondary. A primary dust explosion is the first explosion and occurs when a dust suspension within a container, a room, or a piece of equipment is ignited and explodes. And then a secondary explosion occurs when dust accumulated on floors or other surfaces, right? You think of like rafters. That's when that's lofted and ignited by a primary explosion. What happens is the blast wave from the secondary, and what happens is often the blast wave from the secondary explosion that can cause accumulated dust in other areas to become suspended in air as well, which may generate additional dust explosions. So depending on the dust deposits, even a weak primary explosion can cause really powerful secondary dust explosions. And it should also be noted that the initiating event for a secondary dust explosion might not even be a dust explosion at all. A number of incidents that the CSB investigated, like CTA Acoustics or West Pharmaceutical, they occurred where the secondary dust explosion was initiated not by dust explosions themselves. And we'll get into this, later in the slide deck, but, really, one of the best ways to prevent those secondary dust explosions is to minimize dust accumulation. And how do you do that? Certainly, ensuring good housekeeping. I think anytime anyone talks about combustible dust, housekeeping is always raised. Is a good idea. Certainly, designing and maintaining equipment to prevent dust leaks, using dust collectors, eliminating flat surfaces and other areas where dust can accumulate, if possible, and then sealing sort of hard to clean areas. That's, those are all sort of effective prevention methods. But, along with all of that, you'll want to make sure, I think I mentioned sort of like, design and equipment. You'll want to make sure you're using the proper equipment, the proper design, when dealing with dust accumulation. So, and things like minimizing dust clouds, only using vacuums that are approved for combustible dust. So there's a lot of thought that goes into these prevention methods. As you can imagine. Okay, so what kind of dust are we talking about that can be combustible? So these are, this is just a graphic with some common combustible dusts. Like wood dust and grain dust probably are not too surprising. I think the first documented dust explosion was in Turin, Italy, in a bakery in the, I think, 1700s, where there was, I think it was flour dust that was ignited by I think it was a lamp in a bakery room. So anyway, we'll talk more about this later, but while OSHA doesn't have a combustible dust standard for general industry, it does have one for the grain handling facilities. That's a specific standard at 29 CFR 1910-272, which was promulgated a while ago, I think in the late 80s. So that's just a distinction there, is that I never want to say that there is no, OSHA doesn't have a combustible dust standard, because it does, but it's specific to grain handling facilities. But as you can see, there are a bunch of other combustible dusts, right? Sugar, cornstarch, cotton, metal, the list kind of goes on and on. So in identifying, potential hazards, and conducting a hazard assessment, you'll want to think broad. And again, we'll get to this later, but one good place a good starting point is looking at your safety data sheets. As y'all may know, the SDS requirement, at least, to develop SDSs comes from OSHA's HAZCOM, Hazard Communication Standard at 1910-1200. And that's a requirement on manufacturers and importers. As y'all might know, the new HAZCOM standard was promulgated in May of last year. And we now have a definition for combustible dust. So, if you're not an OSHA nerd, you probably might not think that this is very interesting, but OSHA before the newly promulgated HAZCOM standard was really relying on other guidance in terms of how to define combustible dust for purposes of HAZCOM. So it looked to its National Emphasis Program on Combustible Dust, its NEP. It also said that, NFPA standards define combustible dust. And so it also had a rulemaking that's now sort of, I think it's not even been put on I think it was withdrawn. Yeah, it was withdrawn. So anyway, it was looking to the, its guidance for purposes of defining the dust, combustible dust. But now there is actually a specific definition in the new HAZCOM standard. I went off on a little tangent, but I also wanted to mention that OSHA does have a memo about how compliance officers should conduct inspections of manufacturers and importers when it comes to combustible dust. And that basically says that, COSHA should determine how they've handled available evidence about a product's explosibility. So if there's, evidence that a product has actually been involved in a dust explosion, then it should be classified as combustible dust. Similarly, if there's, results of accepted tests on the product, that indicate it's explosible, that it should be classified that way. And then finally, in the absence of sort of actual events or test data, what OSHA says is the manufacturer or importer can either rely on unpublished test data or on similar materials, so kind of analogizing a little bit, or use available information about particle size to determine the combustible dust hazards of the product. So that's really just a caveat to say that, even though a dust might be identified as combustible on an SDS, that doesn't necessarily mean that the manufacturer or importer actually tested it and determined that to be the case. So I mentioned sort of SDSs as a good sort of starting point, but as you can imagine, especially with liabilities, a lot of manufacturers and importers sort of might overstate the hazard. And I don't want you to think that I'm saying that they are overstating the hazard. I don't say that's not what I'm saying at all. But it just means that testing might not have actually been done. So that is why we recommend actually sampling and testing your own dust to see what the actual characteristics of it are. All right. You might be thinking, how much dust do I have to have for it to be a hazard? So most solid organic materials, and as well as many metal and non-metal inorganic materials, will burn or explode if they're finely divided and dispersed in sufficient concentrations. So even seemingly really small amounts of accumulated dust can cause catastrophic damage. So for example, on this table here, you'll see even as little as 1/32 of an inch of dust over 5% of a room's surface area. And I always think, what is 1/32 of an inch? It's basically the thickness of a paperclip. So for metal dust, the thickness should be, enough. You don't want it to be so much that you can't see the color under the surface. And I know that can be sometimes difficult because dust can be sort of a gray material. And if you're, if it's accumulating, or even, on like rafters and ductwork, sort of a silver material. So one thing, we've heard certainly is, putting some, bright tape down on floor surfaces where accumulations might be expected. So maybe in a yellow color or red color, so that you can kind of see the surface underneath if there are accumulations starting to pile. and I think that there is, and it's also an ignitable dust concentration is light being obscured at 6 to 9 feet in front of you. So OSHA has a publication for firefighting precautions, and it includes that as a rule of thumb. That, the dust cloud, totally obscures a light source at a distance of 6 to 9 feet. Treat that as sort of as if it's in the explosible range, and consider evacuating the area in those scenarios. Alrighty, we talked a lot about this, but basically, combustible dust hazards can be, present in a broad spectrum of industries like food, grain, tobacco, pharmaceuticals. The list kind of goes on and on. There's sort of no bright line, I'd say. And you'll see here, this is from the CSB from 1980 to 2006. 24% of incidents were in food production, 15% in lumber and wood. So those are maybe more of the obvious combustible dust, but there's also 12% in chemical manufacturing, 8%, primary metals, and, rubber and plastics, electric services, also 8%. So definitely a broad spectrum. All right, and just extending on that a little bit, the CSB developed the graph on the prior slide from 2006, but then these are numbers from 2006 to 2017. And again, we had a larger number of incidents occurring in food products and lumber and wood, but also quite a few in the metals industry. So again, the hazard is really not limited to one industry or the other. Alrighty, with that, let's get into standards and enforcement. So here is a list of CSB combustible dust investigations. And there are a couple of things I want to draw your eye to kind of right away. First is that all but one of these investigations involved at least one and more commonly multiple fatalities. So again, these are fire and explosion types of events, and sort of, high severity if they occur. Another thing is just how diverse, the dust types and industries are, and how these events can really occur anywhere in the country. And I won't go through each one of these, but obviously, like, a lot has been written up by the agency on lessons learned and how to prevent and mitigate these types of incidents. All right, so in addition to investigating incidents, the CSB can also create hazard studies. So that's what the agency did with combustible dust. The study was released on, I think, November 9th, 2006, and reviewed the last 3 incidents in that table on that last slide. So it's Hayes, CTA, and West Pharmaceuticals. That occurred over a 2-year period. So this was, concerning to the agency. It saw sort of a trend going on, and because of the impact and the number of incidents sort of occurring over a short period of time, it developed this study. So in this study, it identified 280 dust incidents that occurred between 1980 and 2005, and those resulted in 119 fatalities. So again, just showing how severe these incidents can be. In particular, the CSB issued 5 recommendations to OSHA, one of them being issuing a standard on combustible dust for general industry. And, at the time, CSB's recommendation is based on NFPA standards, which included at the time 654, NFPA 654 and 484. And they recommended OSHA include the following, elements such as a hazard assessment, engineering controls, housekeeping, building design, explosion protection, operating procedures, and worker training. So obviously this is still an open recommendation on the CSB's list. And, since 2006, it's conducted 5 more investigations, which were the 5 top in that slide that we saw, in that table that we saw on the last slide. And those resulted in 27 fatalities. So, again, just a little bit about the combustible dust study. And this next slide, it sort of puts everything together. The CSB's dust investigations, OSHA's rulemaking activities, You'll see the investigations in blue at the top of the timeline and OSHA's, activity in green at the bottom. There's also a call out box for CSB's combustible dust study that we just talked about. I'll also mention sort of that the combustible dust was the CSB's first, what's called sort of a driver of critical chemical safety change. I think these were called like the most wanted action items while I was at the CSB. It changed while I was at the CSB, but anyway, those are sort of just the high advocacy priorities for the agency. With the combustible dust standard, OSHA did go through, I think went through there's this long rulemaking process, but I think it did get through the SBREFA process, which is for, small businesses. I think that is when actually things started to trail off. And then eventually it did, the rulemaking did, get withdrawn. And I think that was in March 2017. So it's been sort of withdrawn for some time now. And certainly, as you can guess, we don't see that going anywhere, at least in the next 4 years. But that doesn't mean that OSHA doesn't enforce in this area just because it doesn't have a study. It certainly does. And it does that through its National Emphasis Program, its NEP, as well as through the OSHA's General Duty Clause. And there are some specific standards that relate to combustible dust hazards that it will issue citations for as well. Alrighty. So yeah, this slide is, kind of just speaks to what I just mentioned, and I'll go through this quickly. Certainly want Val to speak on sort of prevention, the prevention methods. So I think we talked about this already, but the NEP was issued in 2007. So it's been a longstanding NEP, but it was most recently revised just a couple years ago in 2023. And when OSHA conducts these inspections, it's these are comprehensive, detailed, almost PSM-like, process safety management like kinds of inspections, and that'll include sampling. They obviously do interviews, they review records, all design, looking at manuals, all those types of things. So obviously General Duty Clause is typically those are the types of citations we see, but there are also these others that I mentioned, these specific standards like ventilation, housekeeping, PPE, electrical, that are all sort of relevant in this sort of sphere as well. And then just to conclude, I won't get into the specifics of each of these. This slide is really meant to show the way that the standards were written before December 6th of last year. So I should have mentioned, when OSHA does issue its General Duty Clause citations, what it references almost all in every case is NFPA standards. So this slide is really just to let you all know, and I'm sure you all do already, but if you didn't, so as of December 6, 2024, NFPA now has one consolidated standard for combustible dust, and that's NFPA 660. As you all probably know, the combustible dust standards were sort of scattered everywhere. There was 652, which was your sort of foundational background document, 484 for metals, 664 for wood. They were just kind of scattered. So now NFPA has consolidated them into one comprehensive standard, where basically the pre-existing standards are now included as like chapters of this 660 standard. So for example, like the beginning chapters, I think it's like probably 1 through 10 reflect, NFPA, what was NFPA 652. Then you got 664, I think went into chapter 24. Metal 484 went into chapter 22. So anyway, they're still all existing, but they've just kind of been put into chapters. So hopefully this will be helpful to industry, because I know a lot of folks have a lot of our clients have said it's kind of just hard to navigate these standards. One of the things I'll mention though is some certain standards like NFPA 68 and 69, which kind of just, discuss more of like, explosion protection and explosion prevention systems, those types of things. Those will continue to live outside of this consolidated standard. So with that, I just wanted to kind of, discuss the organization of this new 660 standard, but I will pass it to Val to discuss hazard identification and mitigation.
Thank you, Beta. Okay, let's take a look quickly at how to identify combustible dust hazards in the workplace. So NFPA 660 emphasizes the importance of performing a dust hazard analysis, or DHA. And that process helps to facilitate the identification of areas where combustible dust presents risks of fire, deflagration, or explosion. This step is critical for developing effective mitigation strategies and must be completed for all new and existing processes and facility compartments. A facility owner with combustible or explosible materials should ensure that the DHA is completed. The absence of previous incidents is not a valid reason to avoid conducting one. Your DHA is going to be a thorough examination of fire and explosion risks. It will assess potential consequences and identify measures to prevent or reduce those risks. Results, along with any required action items for changes to process materials, physical processes, operations, or facilities, must all be documented. The DHA should include identification and assessment of the areas within a process or facility where fire, flash fire, and explosion hazards are present. Where these hazards are present, identification and evaluation of specific fire and deflagration scenarios should be included, such as determining safe operating ranges, identifying existing safeguards for managing fire, deflagration, and explosion events, providing recommendations for additional safeguards, including an implementation plan. It should also explain how to maintain the effectiveness of these controls over time and account for proper resource allocation. A qualified individual needs to conduct or oversee your DHA, which should undergo review and updates at least every 5 years, regardless of any changes to the facility or your processes. Additionally, a DHA is necessary for new installations, expansions, or upgrades to existing installations. The qualified person or team leader performing the DHA should have experience in conducting DHAs and be deeply knowledgeable about the hazards associated with combustible dust. The team members can include facility operators, engineers, consultants, even equipment manufacturers to help you find what's best suited for your space. The diverse background and expertise needed on the team should encompass familiarity with the process, operations and maintenance, process equipment and safety systems. They should understand the history of your operation, the properties of the materials that you work with, and your emergency procedures. Now, what can we do to manage combustible dust hazards? As you can see here, it's not simple. An NFPA 660 encompasses a wide array of topics and guidelines to effectively manage dust hazards with existing standards. Some of the key components of the new standard at NFPA 660 include risk assessment and hazard identification. You need to provide for conducting a thorough dust hazard analysis. You need to assess explosion prevention systems, conduct risk assessments, and identify potential dust hazards such as electrical installations within industrial facilities. Preventative measures and controls. The standard outlines preventative measures and engineering controls such as the dust collection system and dust collectors to mitigate the risk of dust accumulation. You should consider ignition sources, static electricity, and other potential sources. Housekeeping and maintenance practices. NFPA 660 emphasizes the importance of regular housekeeping and maintenance practices to minimize the accumulation of dust, including a dust collection system and ensuring the proper functioning of all of your safety systems. Training and education. The standard underscores the importance of comprehensive training and education programs for personnel and making sure that they actually understand what their training is. So you want to be not only giving them training, but assessing, do you understand, really what's going on here? Processing and managing combustible materials and identifying ignition sources. You also need to focus on emergency response and preparedness. NFPA 660 provides guidelines for developing emergency response plans and procedures to effectively mitigate the impact of fire and explosions caused by dust incidents. One way to think about all this and to sort of simplify it, I think, is sort of focus on what I think of as workplace safety basics. Look at your engineering controls. Can you make physical modifications to your facilities or your equipment or your processes to actually reduce exposure? Some questions you could consider: has your dust collection system been properly designed by an engineer? Is your dust being captured at the source? Is your dust collector located outdoors? Are you able to minimize ignition sources and contain sparks or flames? Are dust and product conveyance and handling systems designed to minimize dust from spreading? Can you use misting to keep dust from dispersing? Also think about your administrative controls. Is there anything you can do with your work practices, your policies and procedures to increase awareness and training? Have you developed a dust management program, including a risk assessment of all work areas where combustible dust is produced or may accumulate, all potential ignition sources and all means of dust dispersion? Do you properly inspect, measure, and monitor dust accumulations? Do you have effective manual cleanup and housekeeping programs? Have workers received suitable and effective training and orientation? Do you have a solid emergency preparedness plan? Do your employees know what it is? Have you drilled? Have you developed and implemented safe work procedures to minimize fire and explosion risks? And personal protective equipment. Clearly, personal protective equipment is not going to be a control measure when it comes to combustible dust. But where dust is located, you may also have other hazards you want to take into consideration. So you should consider, do your workers have proper respirators? Do they know how to use them? Are they being fit tested? Is their eyewear and protective clothing appropriate? Has personal protective equipment been tested? If you're unsure whether you have combustible dust hazards in your workplace, your first step may be, like Beta mentioned before, to examine all of your SDSs. Is there anything in your facility, according to your SDSs, that could present a fire, flash fire, or explosion hazard? That said, studies have shown that SDSs lack essential information. And like Beta was saying, you never know whether tests have actually been conducted. So a lot of the times you can actually find incorrect information on SDSs. So you don't want to necessarily, or definitely really, you don't want to stop there. So with that, at that point, you're going to want to move on to testing. This is the only definitive way to know if you've got combustible dust in your facility. And if you haven't already, testing is the point in the process where you may want to call in counsel and technical assistance for help. It can be very advantageous to protect from disclosure information exchanged and gathered during the testing, which can be accomplished only if testing is properly coordinated with counsel ahead of time. If you learn that you have combustible dust, then you're going to write that DHA that we've been talking about. And finally, with your processes and facility evaluated, you can prioritize the hazards that your DHA identified and make a plan to manage them. The goal is for your DHA team to agree on a set of guidelines that facilitates an objective evaluation of the risk so that you can strategize and address the highest overall safety hazards first. As you work through addressing the risks you've identified, be sure to document every step you take. As you know, OSHA loves documents, and if you cannot demonstrate all the work that you've put in, OSHA is not going to give you credit for it.
hopefully this has been helpful. And just to tail end on what Val was saying, certainly I think, the most important part, we think of like, there's all this front end work, right, that goes into, developing a DHA. The most important part of all of this, and it goes with IH too, right, is whenever you get recommendations, when you get those testing results back, making sure we do something about it, right? That's what this is all about. So thank you very much all for joining us. We'll continue on with our OSHA webinar series. It's going by quickly, but again, we'll make sure to follow up with you all via email on your excellent questions. I'm looking through the chat now, so thank you all for joining us. Really appreciate it.